Hey guys, welcome to DevOpsSchool. In this video tutorial, we are going to learn about Kubernetes. Kubernetes is developed by Google and it is an open source platform that automates container operations. It eliminates many of the manual processes involved in deploying and scaling containerized applications. After going through this tutorial, I promise you that the concept and understanding of the Kubernetes will be absolutely clear to you. But before we begin, let me inform you a few things about us. DevOpsSchool is one of the leading platforms which offers DevOps, cloud and containers technology training and certification programs for freshers and established professionals who wish to update and consolidate their skills in the dynamic IT scenario. We ensure that the training solutions are delivered by highly experienced domain experts with practical working experience in various verticals. You can join our all training programs globally through online platforms, and if you're looking for classroom workshop, then we have regular batches available in Hyderabad and Bangalore. Check out the dates and enroll with us for our upcoming batches. For more info, link and contact details are mentioned in the description below.
Okay, so finally we understood master and then node. Now let's move on. So yeah, ultimately we have a three component in worker, aka node or aka minion. Kubelet, which is a main Kubernetes agent. Container engine, which is Docker by default, can be Rocket, Cryo, Containerd, and many more. Networking services, yes, kubeproxy, each node you have it. So this is the stuff. So this is the typical flow. Again, it's a little bit different illustrations of the same image of the architecture. Master, you have a cluster store scheduler, controller manager, API server. Now again, if you node, you look at this kubelet, kubeproxy, and container runtime. Whereas kubelet and kubeproxy talk to API server for their cluster management done and networking services done. So kubeproxy needs to talk to API server for the networking services. Kubelet talks to the API service for the controller manager and scheduler work, and which you have elaborated already in detail. So yes, so in a short, if you look at this, kubelet is it monitors API server for the changes, responsible for the pod lifecycle. Now the question is, what is a pod? I'm going to come back on it, but yes, remember kubelet initiate a pod. Just remember that line, and it helps you to which helps to manage the life cycle, pod life cycle. Again, what is a pod life cycle? I'm going to discuss in some time. I hope you remember the container life cycle, which we have covered in the last session. Now again, kubelet reports report nodes and pods straight to the API server. Pods liveness and props can be done by the kubelet. Now, what is a pod liveness and props? I need to come back on this and discuss with it. But yeah, for time being, this is the feature. Now, nodes to have a kubeproxy, which is a networking which manages the network proxy IP tables, implement services. Now, what is the services? I need to come back. Routing traffic to the pod, that is through the services again and again. I need to come back and do the load balancing. In a short, it's a Kubernetes networking services. Now, container runtime. Again, download images and run containers. We know that containers runtime interfaces, Docker, and many other. So in short, this is the node. Okay, so apart from that, there are many other components. Depends on your requirements. You may have it. You may be having a DNS component, domain name services component. You may be having ingress component. You may be having dashboarding solutions component and stuff like that. So many component networking solutions also. You network drivers, you must be having it. So all these things depends on the requirements. Depends on your need for the project. So you may have multiple components. Again, these are the components, which is not a core component. So I'm not discussing in detail because it's the add-ons component. When you need it, you go and get these components from the github.com to get going, get running. So some of the components are stable, some of the components are in the production, some of the components are still under the development or maybe are not in the production. So again, this is a learning things. So gradual learning things will get going as you get started. Now, so we discuss about master, we discuss about the nodes, and I hope that is clear now. But now we have to discuss about human beings also. Now remember, human beings who is doing nothing but declare his desire. Okay, declare his desire. So we need to understand what are the declarative model which we have, and in which you can desire what you want. How to declare, what to desire. Again, remember, in my word, how to declare, what to desire to the master. This you need to learn. And this is the only job you have, trust me, in Kubernetes. Because I told you so many times, Kubernetes will take care of everything, whatever you desire. Desire once and forget it. Kubernetes will take care of the rest of the things, his own. The Kubernetes, the infrastructure can be very small or very large. Everything would be taken care by the Kubernetes. So yes, let's understand and let's learn how to declare and what to desire. In terms of how to declare, so yes, we declare nowadays. Typically, if you look at the trends nowadays, how to declare the things. So we declare in the YAML or JSON. Not only about the Kubernetes I'm talking about. Any other automation tool also you look at this nowadays. Start declaring in YAML or JSON. Why this is the format we use? Because easy to write, easy to understand, easy to maintain, easy to get and share that as the objects and all, very fast actually. So nowadays YAML and JSON, which is become a global standard for declaring the desire. Now, if you understand this thing, why we started declaring? So earlier we used to use the programming languages such as Java, C++, PHP, Ruby, Python, Perl. These are the programming languages, and you used to write these programming languages in their own specific extension. But now we don't write those programming languages. It's simply because we have a hell lot of libraries which is written. Just need to tell what libraries you want, and then you get it. So you need to write this what library you want. For that, you don't need to write a program for it. So you need to declare your desire. You need to declare the desire in YAML or JSON. But remember, yes, you can declare the desire in YAML or JSON, but API server accepts only a JSON format. Okay, which we have discussed in the previous slides. So yes, this is how you declare. Now the question is what to desire in the declare manifest file. Pods. You want the pods. You desire a pod. Now what is a pod? Just said I will come back to this. But we know very well pods has a container. Containers come from the images and stuff like that. So yes, what to declare? How many pods you want? And the pods should be having which pod? What pod you want? Okay, as part of the slides, I want the 3 pods. Okay, I want 3 pods of what? Nginx. I want 10 pods, or I want 10,000 pod of what? XYZ image. Okay, so this is what you have to declare. Pod. You need to declare pod. So here, this is important. You need to declare. You need to understand the declare model. You need to learn how to write a YAML for the Kubernetes, or how to write a JSON for the Kubernetes, and then what to desire. And what to desire is the only learning you will have it. Pod. What to desire? You desire a pod. Okay. So this is what happened. So I desire 3 pods of Nginx, and you see I got the 3 pods of Nginx. Now if you look at this, these pods you got created in the node. Okay. Here evenly it is distributed by the scheduler. Now you know all this, how it works. Controller, scheduler, cluster store, API server, how it works. In the node, what you have, how it works. You have a kubelet container engine and the kube proxy and all these things. You know that very well. So now you know that in the pod you declare a desire in YAML or JSON, you desire a 3-pod of Nginx, and you got the 3-pod of Nginx. How? You got to know this one already. Now, suddenly, what has happened? What has happened? One node is not available. Remember, I told you node has a controller in a kubelet. Controller communicate with the controller's manager. And if the controllers do not communicate with the controller manager, then that node is become unhealthy. That means that node is not healthy. But the problem here is that node which become unhealthy because of n number of reasons had Nginx, one of the pod where you desire. I desire three pod of Nginx, and here desire and actual is mismatch. Now, how they evaluate this desire and declare mismatch, we have discussed here. API server, controller manager, kubelet, all these things will intervene and then do the things in the loop, and we'll find out, okay, desire and actual is mismatch. But suddenly, if there's a mismatch, then who will manage the desired state in Kubernetes? And how we have discussed, and mismatch has happened. One nodes become unstable, no problem, because cattle business, I'm in the cattle business, I'm in the operations, I'm in the production. Third pod got replaced, third pod got created in the any on the other available nodes. Now, once the third pod got created, running healthy, desire and actual is mismatching, and now no need to worry about it. Remember, here you did not get up in the night or the production is down or stuff like that. You did not get any notifications. There's no P1, P2, P3 and stuff like that. Who did your work? Kubernetes. Something similar solutions what you have, which Google is using in form of Borg and Omega to manage the entire such an enormous data, infrastructure of the data servers, with the servers where the application is never be down, highly available, highly secured, and highly scalable. So yes, this is the way the Kubernetes can do the things and do the wonder. So now, yes, now the question is, because everything is done by Kubernetes, you don't do anything except desire. Again, except desire, do not do anything else. Now the question is what to desire, and I told you in the last slide, you desire what? You desire pod. I need 2 pod, 3 pod, 5 pod, 6 pod, 20 pod of what? Some images. Pods as a container. Now what is a pod? Again, I'm going to come back, yes, but you are going to learn what to desire. And then remaining sessions, we're going to focus on what you can desire, because once you desire, Kubernetes will take care of it. You don't have to worry about it. But the only thing which you have to learn is what to desire. So you need to desire a pod. You need to desire a controllers. You need to desire a services. You need to desire a storage. What is a pod? What is a controllers? What is a services? What is a storage? All these things we are going to understand in the next upcoming few days. And again, this is not exhaustive list. These are the only few desire objects which you have it out of so many. So pod is the most important object which you desire. So now we need to understand what is pod. Okay, so far, do you have any questions about the architecture? Because we are done with the architecture, master, nodes, and the human beings, what he desire in what format and all stuff like that. So do you have any question on the architecture front? Any questions?
Is there a component called Kube API server?
Kube API server is the same one which I discussed. That's the API server of your Kubernetes master. Yeah, same one.
Yeah.
Okay, so I believe there's no questions on the architect front. So let's learn what to desire. You need to desire a pod. So now the question is, what is a pod? So we are using virtualization technology from last 20 years, I guess, 15 plus minimum. Now, please try to understand, because the pod definition is like pod is an atomic unit of scheduling. That's all in Kubernetes. Now, I need to elaborate a little bit of it in what context. So we are using the VM technology. So now let's say, remember here, earlier we wanted to run applications, software. So we were running the physical box. That's out of the way, out of the context. Now we don't run anything nowadays from last 15 years in the physical servers in the production. We run inside the virtual machines. Right? So now if you want to run applications, we were running in the virtual machines. Now who manages the virtual machine? Hypervisor. Right? You have so many hypervisor such as KVMs, VirtualBox, VMware, Hyper-V, and many more. So yes, we wanted to run application in virtual machines. We run it, no problem. Who manages the state of the virtual machine? Hypervisor. Now we want to reduce the running cost, software running cost. So now what we decided? We want to run application inside the container. The question is, who manages the state of the container? Docker. Now how Docker works, we have already discussed. But ultimate thing is, yes, inside the container, you run application and container is being managed by Docker. But the problem here is Kubernetes don't understand virtual machine. Kubernetes don't understand containers, because containers is understood by Docker. So what Kubernetes can understand? So Kubernetes can understand pod. Yes. So in that context, the similar line, hypervisor atomic unit is VM. Docker atomic unit is container. Kubernetes atomic unit of scheduling is pod. That means Kubernetes understand the pod. Kubernetes, when you want to do something with the Kubernetes, that's atomic unit. You want to, when I say do something, means you want to run app in Kubernetes. With Kubernetes, you create a pod. You wanted to run app in the hypervisor world, you created a VM. You wanted to run an app inside a container, you used a Docker. So same way, if you want to run app with the help of Kubernetes, Kubernetes can help you to create a pod. So pod is an atomic unit of scheduling in Kubernetes. Okay, is this the clear things? Guys, I need a little bit of interaction, because I'm alone in room. So if you do not interact, I'll get lazy. So
Yeah, we got it.
now there's one more line I'm going to make it. Please read my lines. See, we all know VM is running. See here, VM is in running state. I'm saying VM. Yes, VM is in running state. When? You tell me. When VMs is in running state? when VMs is in running state.
When the hypervisor is up and application is running.
No, so I see you start. See, I'll tell you this way. You created a VM in the hypervisor. Will it run?
You have to start the VM.
You have to feed the operating system into that, right?
Yes.
Correct. So inside the VM, see, what I'm trying to tell you here is very simple thing. VM is running because of operating system inside the VM is running. Now the question is, how this operating system is running? When operating system is running, because of the PID1 is running, and PID1 is your system D, kernel system D. So your kernel is running because of the PID1 is running, PID1 is running, operating system is running, VM is running. The moment you stop the PID1 through the shutdown process, operating system is not running, so VM is also not running. So VM is so tightly coupled with your operating system. Operating system stop, VM stop. Operating system start, VM start. Is that clear?
Yes.
Okay. Now let's discuss about the containers. We have discussed containers also. How these containers are running? Tell me. How the containers are running? I said running. How come? I have told you in the last session itself. How the containers are running?
With the input of image.
I said running. Containers is created with the help of image. That is very defined process. You said just now. But I said how the containers is running, because there's a difference between the creating a container and running the container. So how this container is running? So I think you forgot, but let me remind you. I have stated one line multiple times in the last session. Container is running because of the PID1 of the container is running. If PID1 of the container is exited, your containers will get exited. So now you see that here, how this Docker manages the state of the container, but container is running only when the PID1 is running of the containers. If the container one, a PID1 is gone, container is gone. So here, container state of the container management is done by the Docker. Now, the similar line, see here, VM is running because of operating system is running, container is running because of PID1 of the container is running, and pod is running. What do you have in the pod? I've been telling you since morning. What do you have in the pod?
Containers.
Number of containers.
Yes, containers. So here, sir, pod is running only. See that Kubernetes understand the pod. They don't understand the containers. Kubernetes understand the pods of Kubernetes initiate a pod, and pod has a container. So pod is running only when in pod a container inside the pod is running. If the container inside the pod is stopped, pod also is not running. So this is so tightly coupled. Pod is tightly coupled with the state of the container, and container state is coupled tightly coupled with the PID1, and PID1 state of the thing is been done by the images and with the help of the Docker engine. So tightly. Now one more perspective I'll give it to you on this slide. Did you ever come across a situation where your hypervisor companies like VMware, VirtualBox, KVM or Gen, Hyper-V, Microsoft, is telling you boss, you need to run only this operating system in the VM. Have you come across any such situation in the past? Have you come across? Have you come across any situation in the past, such as like your VM hypervisor companies are saying, no, you need to only run this operating system in the VM. You can run any operating system, right? You can create a VM using any operating system, right?
Yes.
Yes. In the last day session, have you come across a situation where Docker is stating, no, boss, you can only run this image only in a container? Have you come across? You can run any images. You have more than 1 lakh images on the hub.docker.com alone. You can run any image and it will create a container. Basically any image. So what I'm trying to tell you here is hypervisor companies don't dictate what operating system you want. Same way, Docker do not dictate what image you want to run inside the container for the container. Same way, Kubernetes also says, I will manage the state of the pod. Inside the pod, you can have any container. I said any image, any containers, you can run it, no problem. So it's so simple. What is a pod? Pod is an atomic unit of scheduling. Pod is understood by the Kubernetes. Pods has a container. The same way, manage of the VMs is done by the hypervisor. Manage of the container is done by the Docker. Manage the state of the pod is being done by the Kubernetes. Similar way, the hypervisor company never said which operating system you should install in the VM. Same way, Docker never said which image you should get in the container. Same way, Docker never said what containers you want to run in the pod. You can run any container. Hypervisor companies say they will manage the state of the VM. If operating system is running, VM is running. Docker says I will manage the state of the container. If the ID1 of the container is running, I will run the container. Same way, Kubernetes says I will run the pod only if the container inside the pod is running. I will not run the pod if the container inside the pod is not running. So now the question is, did you understand a little bit of it? What is pod?
Yeah, we got some idea.
Yep.
Yes. So yes. So pod has a containers. Pod may have a multiple containers. So pod containers always run inside the pod. Pods can have a multiple containers. That is there. Now the interesting things start here in this slide. In the Docker session, I've been telling you containers powered by the Docker get your network namespaces, kernel namespaces, and all stuff like that. But here things changes. Here container don't get, again I'm repeating, container don't get all the namespaces. All the namespaces. Would you mind if anyone can help me to recall what are the namespaces containers gets in Docker by the Docker by default? Anyone remembers that namespace's name?
Net.
Yes, net for the networking services. Wonderful. What else? Mounts, remember? For the storage.
Yes, sir.
Yes, mounts. Tmap,
Volume.
process map. Correct.
User.
And, user space itself is a container actually. So here, what happens in the Kubernetes world? Kubernetes manages the pod, and here network layer don't get mounted at the container level. Network namespaces, okay, get attached to the pod. Volumes, if you want to have external volumes get attached to the pod. Again, I'm repeating, IPC table, volumes mount get attached and network get attached to the pod. So when network get attached to the pod, when IPC table get attached to the pod, when volumes mounts get attached to the pod, that means, and in a pod I told you, you have so many containers, you may have so many containers. So the wonderful thing is all containers in the pod share the same environment. That means all containers in the pod will share the same network, same IPC, same amount. So it's just like it's a physical machines, you are running 10 process. Each process is become one container like that. So you still have a one network, one mount, one IPC. So that's a wonderful thing. So yes, it's a ring-fenced environment. Networks take kernel namespaces and stuff like that. Specifically, the mounts, IPCs, and network get attached to the pod level, not at all container level. Here, a little bit of the architecture changes has happened. Yes, one pod may have a multiple containers, and this is called tight coupling. Sometimes what happens, developer says, listen, we are in a tightly coupled world, monolithic applications, not microservices. Okay, now it will take at least 2, 3 months, 5 months, 6 months to separate these two components. It requires the development effort, but still you want to migrate to the Kubernetes world. So for time being, you want to run application and a database server, so maybe two applications in the same atomic unit of the pod. Again, or get the network, or get IP address, or get amounts shared across the multiple containers. So yes, you want to run in the tightly coupled environment. In that case, this is what can have a multiple container tightly coupled. And wonderful thing here is each of these container, if they want to access each other, they can access through the local host. So because of the pod get a network, here container don't get a network. This is called loose coupling. This is one of the best scenario which you have. So one container, one pod. This is the best practices because pods get a network, and this is a loose coupling. So now you try to think over why this one image is good, one image is not good. Look at this.
High availability.
Yes. So see, pods get a network. Here in one pod you are running n and 5 nginx. But ultimately, available nginx will be only one because all these nginx is running, but only one can serve the purpose of the load balancers. 4 will be waste of the resources, CPU, RAM, and stuff like that. So yes, good practice is one pod, one container. If you have one pod, multiple container, probably you have a requirement of the tight coupling, which I have discussed. Sometimes you want to run multiple services, the same pod, because of the scope of the accessibility, local host and stuff like that. So in that case, you can use multiple containers. To the front end, load balancers and all, availability and all, you can only access one pod from the outside. So the question is, pods are atomic unit of Kubernetes, and also pod can scale from one to many. Pods are atomic. Pods can scale one to many. One pod to 1,000 pod. It can scale. Now you have a one pod here. See in the ready state, and when you scale, it will become a pending state. So this is a life cycle. Again, it's not a complete life cycle. There's few things which is not mentioned here, but that's not needed also. Before talking about this life cycle of the pod, anyone remembers what was the life cycle of the containers? Anyone would like to tell me?
The container create, start,
Right, yeah.
then
Correct, yes. The container can be created, started, stop, restart, pause, unpause, kill, all these things. So yes, something similar. Here you have a pod lifecycle. The pod lifecycle, the moment you create it, get into the pending state. And look at this image very carefully. I would like you to focus on the images. Here you have a one pod, and here in the pod label you have a network, IPC, and MAU. All these namespaces at the pod label. And now you see the container icon is gray. And I told you, pod is running only if the container is running. VM is running only if the operating system is running inside it. Container is running only if PID1 is running inside it. Don't forget this concept. The pod is running if the container is running, but in the first image, which is the phase of pending, you see the container is gray. That means it's not running. So pod is pending. If you look at the another pod which is running, so here container is running, so pod is running. But if you look at the another image, which is the last one, containers got failed because of XYZ reasons, so pod also get failed or succeeded or whatever it is. So this is the life cycle of the pod: ending, running, succeeded, failed.
And I
So
have a
now,
question here, Rajesh. Let's say when we have multiple containers in a pod, if one container fails, so what will be the status of pod?
yes, that is a very good question actually. And I was expecting. Thanks for asking this question, because this is a typical question. So here I just said pods is running only if the containers are running. I said containers. So yes, if one container is running and one container is failed, the state of the pod is not healthy. That means it's not running. It got failed state. Okay. If all containers are running, pod is running. If any one of the containers is not running, pod is not running. If any containers, and sometimes what happens, sometimes you run the container runs successfully and exit. At that case, containers pod is not running, but it got succeeded. That means whatever the work you were supposed to assign, it got work, but it's not running. So these are the states. So yes, to answer your question, yes. If all the containers are not running, and pod is not running. Simple.
Okay.
Now you see here. Here, if you look at this, pods get C groups and namespaces. In the Docker session, I discussed Docker containers get a C groups and namespaces. So this is the difference. You have to understand this. Now, I also said pods has a multiple container. Now also I said pods get IP address from what? Kube proxy. So now if you look at this image here, you have pods get IP address, and you have two containers running. Inside the two containers, one container is you are running on 80 port, and another container which is running internal 5000 port. So how can you access the one which is running on the 80 port? Again, obviously you will have to use IP address and port. So this is the way you can access these two ports, and internally 80 to 5000, they both these containers, they can interact with each other using the localhost scope. So this is the part of the pod which you can see that. But yes, a good practice is one pod, one container. That is a good practice. So now here you see inter-pod communication. So now pods get a container, one pod, one container. I just said pods get IP address, and this IP address gets from where? Kube proxy. And this IP address can be resolved only over the pod network. Pod networking is again, we'll come back to this networking topics sometime, but pod networking is been managed by Kube proxy. So each node you have a Kube proxy, and these all Kube proxy talks to API server and create a one pod networking layer. Okay, based on the some of the drivers and algorithm which I'll discuss in a little bit of time frame. Then all this interacts. So yes, let me tell you clearly, IP address of the pod assigned by the proxy with the help of the network driver installed by the administrator of the Kubernetes. And pod networks, pod IP address never interact with the physical IP address. They have the different layers, and that we call it a pod network, empowered by various different kind of network drivers such as VNet, Calico, Channel, and so many. We'll discuss on this. I don't want to complicate this one. So here interpod communications happen like this. Yes, each containers, they talk to each other through the local host, which I have told you. So yes, in a nutshell, pods is nothing but one or more containers. Your application or service is the most basic unit of work, unit of scheduling. It is infernal. Yes, it is infernal. No pods is ever redeployed. At automaticity, they are not. They are there or not. So this is the some of the advanced topic. I'll go discuss a little bit later. So this is the pod. So far, did you understand the pod now? So we have, remember, as part of the understanding what to declare in YAML. So in a YAML, you have to declare the pod. And pod we have tried to understand many of the things through the discussion. But ultimately, the pod is your applications which you want to run inside that. Make sense? Any question? Guys, any question? Okay, guys. Now the next question is, what is the not only object? I said so many objects are there you to learn to declare inside a YAML or JSON file. So what is the not only object which you have? There's so many objects which you have. What's the only one most important atomic unit? But there are many higher level objects, and which I'm going to discuss here. So yes, you look at this. Here you declare your desire in YAML or JSON. What do you declare here? See here, find is equal to pod, and you got the pod. But many other objects which you have to learn. So can I assume you are clear with the concept of the pod, and to move on to the next object which you need to learn to declare? Yeah.
Yes.
Okay. See, you want one pod, so you declare kind is equal to pod. So that will create a pod. But also, I stated, pods can be scaled one to many. You can create replicas. If you remember, somewhere in the past, I'm also said replica sets. Kubelet manage the replica sets and also like that. So yes, pods can be scaled. So what about if you want, let's say, 10 pod, 20 pod, 30 pod of the same image? Okay. So what you want? So the object which you use to create a pod is a pod itself, kind is equal to pod. But when you want a multiple pod, you want to replicate the pod to one to many, there's another object which you have to use, and that we call it replication controller. Again, remember, there's a two word here. You have to be very careful. Replication controller, and remember the controller, which controller manager I was talking about. So here, replication controller is one of the controller. Okay, one of the controller in which there is a one replicas there, which can help you to create multiple. Again, read my lines. Replication controller is one of the controller which out of so many controllers. Replication controller helps you to create a replica, helps you to scale the pods one to many. At the same time, At the same time, it always manages your state and desire. That means, let's say if you create a replication controller of 5 pod, and because of one reason for that particular replication controller, it become a 4 pod. Replication controller will inform that controller manager saying that, boss, I have only 5. Desire was 5. Sorry, I have only 4. Desire was 5. So now scheduler and the rest of the things will work and then create a remaining 1 pod missing as part of that controller. So yes, in a simple way, I don't want to complicate too much, but if you want to scale the pod to 1 to many, you use the replica set. You create a replicas, but you create a replicas through the replication controller. So that way, if the one of the pod is going down, it should be automatically replaced instead of you getting up in the night or early morning through the P1, P2, P3 and support, and you do that. So it will be taken care by the replication controller. So yes, 1 pod you want to make it scale to multiple, you can use the replica set, but replica set is controlled by replication controller to manage the state of the desire and actual. Now, is that clear? Replication controller?
Yes.
Guys, let me tell you here one more thing. Replication controller got deprecated. Yes, I said deprecated, not removed. Deprecated means it will be removed in next 1 or 2 years, whatever it is, the time frame, by 2020. So now the question is, how can I do the replication? I mean, how can you create a multiple pod? What has happened? Developer community have demanded to the Kubernetes community saying that not only we want to create a we want to replicate the pods to 1 to multiple. That's a good feature. At the same time, I want that desire and actual to be managed automatically. That's also good feature of the replication controller. But I want few more features. Those features are like automatic versioning, automatic rollback, automatic upgrade, and stuff like that, which is missing in the replication controller. So they introduce one more object called deployment. So deployment has a feature. Again, I'm repeating, deployment has a feature of replication controller. So you can replicate a pod to 1 to many. Deployment also has a feature of the controller. So that way desire and actual is been matched. But also they have a multiple features like a versioning, a rollback, and rolling updates, and many more. So these are the primary higher level objects in Kubernetes which you need to know to declare in YAML or JSON, so Kubernetes will act upon it. Okay, so yes, pod, replication controller, and deployment. So I'm going to come back on the pod, replication controller, and deployment a little bit later, more on into that. And again, we have a whole 3-4 days we're going to spend on this also. Our next question is, what is services? Services. So what is the services? So let me give you the little bit of the glimpse of it. Services. If you understand my discussion, look at this here. Now we have understood all building blocks of Kubernetes. We have discussed master in detail. We have discussed node in detail. We have discussed pod also in detail. We have also discussed the what to declare, what to desire in YAML or JSON, pod, replication controller, and deployment in your laptop to YAML JSON format and send to the API server. All these things we have declared. And you know that Kubernetes will run all these pods and stuff like that. The question is, how can you access it? That is the question. How can you access it? Okay, there's a 2 access which you have to understand. Okay, let me probably depict some of the sample images of it. This is my Kubernetes cluster. This is one node. This is one node. This is one node. This is one node. This is a web server. This is a app server. And this is a database. Now you see, this is your Kubernetes. The question is, web server should be accessible from outside. I hope you're getting me. Now, then they will hit this is a load balancer. They will hit load balancer will resolve to one of the web server. Web server will talk to the app server, but app server are so many. So now again load balancer has to be created, and all this app server will talk to this web server like this. The same goes with the database. I hope you get it. I'm not very good at the drawing here now, but I hope you got it right. There's multiple web server, multiple app server, multiple database server. App server, which is the front end for the applications. The application server has to be talking to the web server and database servers will talk to the app server. And there's so not one instance, multiple instance, multiple pods. And these pods are running across the cluster. How can you access load balancer? That topic I'm talking about. Do you understand the problem now?
Yeah.
Yeah. And that answer is hidden in my next discussion. That is the last discussion, I probably believe, before going into the demo part of EKS. This last discussion is services. Okay. So the solution is services. Now we are going to discuss about the services. What is services? What are the kind of services? How to create a services, how it works, how it behaves. All these things we're going to discuss about that. Nature of the services. We have a lunch break now, so we'll after the lunch break. How the services talk to the pods. All these things we're going to discuss in some time. And this is the most important session, I believe. So yes, as part of the declaration, what to declare? You're going to declare in YAML or JSON pod. You're going to declare application controller. You're going to declare the deployment. You're going to declare the services. Unlike that, we have so many objects, API objects, you to learn to declare in YAML or JSON and give it to the API server. So the things Kubernetes will take care of it. So you're going to spend time only understanding these API objects and the behavior of it. Because I told you, Kubernetes will bring happiness and wealth both. By doing all of your work will be done by them. If you declare well, this is the only learning you have to learn from this session. Got it?
Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest. Want to study further? Subscribe to our paid membership to get a deep dive into each and every topic. Do look out for more videos in our playlist and subscribe to our DevOpsSchool channel and hit the bell icon to learn more. Keep learning.